Hello, my friends. Welcome back to another session of MRWC. Oh, the joy. Well, here we have two polynomials, g of x and h of x, and we're supposed to graph each and then answer some questions. So, these do look very much alike. They have the same intercepts. So, what I recommend is that the first thing that you do is that you mark those intercepts. So, x minus 3 would put you at positive 3. And that's the same for this one here. Okay, that's this one right here. X plus 7 puts you at negative 7 on both of them. So let's mark those points right there. And we have x minus 8, which puts us at positive 8 for both of those points. Okay, and that's the intercepts. Now, we also have, let's think a little bit about end behavior. So for the first one, if we count the exponents, so this has an exponent of 1, this has an exponent of 1, this function is degree 6, and it is positive, right? There's no negative here in front. There's no minus x on an odd exponent. So this is a positive even-degreed polynomial, and so therefore it will start and end in positive land. Starting and ending, of course, is a metaphorical description. It doesn't start or end. And for this one over here, we have also an exponent of 6, a degree of 6, and also positive. So this one has the same end behavior as the first function. So I put those black dots there to remind myself that my function has to exit out through those ends. Okay, and so then I'm going to think about bounces and hitches. So the x minus 3 has this one right here. This is a bounce of degree 4. So this one is going to bounce right here. And this one is also going to bounce. Bounce. All right, and then x plus 7. This one here is just a simple, this one right here. This is a simple cross. So I'm just going to write cross. But over here, x plus 7 is a hitch because it is degree 3. Okay, the exponent is 3. This one right here, right, that's 3. So therefore, that's a hitch. And then for 8, both of them are just simple crosses. Okay, so for that green dot there, both of those are going to cross. So let's look at the actual graphs. Let's try graphing this. And I always recommend you do a dry run before you actually graph it, especially if you have using a pen or something like that. So I'm going to come down here. I'm going to cross. Then I'm going to come up, and it's going to bounce down. And I'm going to come up, and I'm going to cross. And that's it. So let's do that. So I'm coming down, I'm crossing, I'm coming up, and I'm bouncing, and I'm coming up, and I'm crossing. And so that would be the graph for the one on the left. For the one on the right, I'm coming down. This one's a hitch. I forgot to do my dry run, but that's okay. Then I'm going to come up, and I'm going to bounce. And I'm going to come down and up and cross. So, these look very similar. The only real difference, as you can tell, is that this here is a cross and this here is a hitch. The degree 4 polynomial, because I'm a flawed human being, I have a hard time making that clear. Let me make sure we can see this here. But the idea, if it's degree 4, so this one here, this should really almost be flatter the higher the degree. But for us, generally, we don't care. I'm not going to dock you or, take off points because it wasn't quite right. But any multiple of 2 is just going to give you a bounce. And same thing with the hitches. So if you have degree 3 or 5 or 7 or 9, they're all hitches, just some are blockier than others. Some are starker than others. The cubic hitch is the most fluid and laziest of all. And then after that, they get blockier, meaning they blockier. Okay, number 2. Write a piecewise function for this graph. All right, that sounds like fun. Okay, so this red one here is clearly a line. It has so it's going to be y equals mx plus b. It has a y-intercept, so something x plus b. The y-intercept is 3, so I can already put a y-intercept of 3. And the slope, well, the slope appears to be 2 because you have a run of 1 and a rise of 2. So rise over run is 2. So this equation is y equals 2x plus 3. But the domain is limited to where x is less than or equal to 0. Because here, at this point right here, x is 0. And anything to the right is some other function. And anything to the left is that line. Okay, so this is our first piece of this function. Next, we're going to do that blue part. This blue part, if I did the whole line, it would be y equals 5. And, right, it's a flat line with no slope. But there's restrictions in the domain. So this is only between 0 and 3. So x is between 0 and 3. The 3 is included, so I have to put a little line underneath. And then we have to say, comma, except at x equals 2. Or you can also say x does not equal 2. And that's a restriction in the domain that lets us realize that there's a hole. So about that hole, well, it's down here, and this is also simply y equals 1 at or if let's say if x equals 2. Next, we have the green part. This is clearly a parabola. Now, normally, a parabola would look like this. Right? It would, again, sorry for my flawed curve. But this is an upside-down parabola. So this would be like y equals negative x squared. But not only that, it's shifted. It's shifted 3 units. Normally, parabolas have their vertex at the origin. But this vertex here is 3, 4. And if you remember from IM3, that means that the h is 3 and the k is 4. And so that means that this is not y equals negative x squared. This is y equals negative x minus 3, close these parentheses, squared plus 4. Because the vertex is given at hk. So that's our function. And again, we have a problem with the domain. It's not the whole parabola. This part's not even there. This is only where x is greater than 3. And now, my friends, we have all 4 pieces of the function. And they're nicely color-coded. And they gave us a nice little block down here. But basically, it should read kind of like the next problem. So we can say f of x. It is f of x, right? It doesn't matter. Okay. F of x equals, let's start with the red one, 2x plus 3. Let's save some space. 2x plus 3 if, what do we have? X less than or equal to 0. Then the next one is the blue one. Y equals 5, and that's between 0 and 3. And the 3 is included, right? And the 2 is not. Next is the dot, which is just y equals 1 at 2. And finally, the green part, which is y equals minus x minus 3 minus x minus 3 squared plus 4. And the domain was where x is greater than 3. Fantastic. Okay. All right. There's your piecewise function. All 4 parts are there. Should I zoom out? Would that help? Okay, so I put all of that together, and everyone's happy, and we can move on with our lives. Oh, hey, did I make a boo-boo? Not that that's possible. But it appears to me that that parabola, that I added that stuff on. I got confused there. I thought that was already there. I added that on. Actually, this, if we use the window convention, this function ended at 5. So a little addendum here. We're going to modify this domain here a little bit. X is between 3 and 5, where we include the 5. And so that's going to change our answer down here as well. So this is going to be 3x less than or equal to 5. Fantastic. Okay. Well, so now we have that. So let's do the same thing with the other one. Well, this first part here is a line, right? This right here is a line. Now, if it's just y equals minus x plus 2, that's a y-intercept of 2 and a slope of -1. And we could easily graph that. Oh, circle tool. I forgot I was doing that earlier. Okay. And this goes through here. Kind of like that. But it's only to where x is less than -1. So all of this gets deleted. I hope, is that going to delete everything? It is, huh? You know, let's just redraw the line. and I'll just stay to the left of -1. So we start up here, and we stay to the left of -1. So we terminate like right there. And we have a little open circle here at the end. And that's that. That's the red part. You did fantastic. What are you talking about? Hooray. Wow. Okay. And now x squared where the domain is -1 to 3. So from -1 to 3, so normally a parabola would, have its vertex at the origin. Let's zoom in a little bit. We're a little bit. This is a little taxing here. So, all right. So normally a parabola would look like this. It would go to -1, -1, positive, +1. Then we would go up to 4, 2, 4. And then 3 would be all the way to 9. So that would be like approximately here. And it would look like this. So we have this right here. Wow. For me, that's really good. I'm usually very bad at graphing stuff. -1 is included, so I'll mark that dot here nice and big. And then 3 is not. So I did make one little mistake here, if you call it a mistake. We need to have an open circle here at the end. So we'll just like do like that. Okay, so that's that. And that's at 3. Okay, good. Then from 3 to 5 inclusive, it's just a flat line. It's just, in fact, I'll just use this tool here. From 3 to 5, it's just like this. Can I get to 0? There we go. And we have to make sure we mark those dots at the end so that people know that those points are included. Okay, this point is included, and that point is included, and that's it. That's our function. That's the piecewise function. But we're not done yet because we have these things down here in the bottom with number 4. So let's look at some of these. F of 0 is right here, and it is 0. F of -1 is right here, and it is 1. F of 3 is all the way, oh, it's not this one. Don't tell me it's 9, because it's not. It's this right here, and it is 5. And the next one is -4, and -4 is this point right here, and that is 6. F of 6 is not there. D and E. Does not exist. F of 4 is right here. This point right here, and that is 5. This concludes our test. I hope that was helpful to you. Please like, share, and subscribe. And I will catch you next time. Buy my merch.